So we look at question 7. Our function given is piecewise. And this question guides us very good. They will ask us find the limit for this function when x approaches 0. Negative. Power negative means from the left hand side. So power positive means 0 from the right hand side. And then only we can evaluate the x approaches the value 0. Then hence determine whether this function is continuous or not. Give your reason to your answer. So we will focus this first. So when we get a piecewise function here, as we can see, we get a piecewise function here. We have to simplify first. Simplify our modulus into the piecewise so that we can take the corresponding function with its domain given here. And then we draw out our interval. So for this square root x plus 1, we're going to simplify it. Modulus x plus 1, we're going to simplify it as modulus x plus 1. When we express in piecewise, it will be positive for x plus 1 greater equals to 0, and it will be negative for this x plus 1 less than 0. So we try to simplify it. For the domain x plus 1, we move the 1 to the right hand side. And then we simplify the function negative here, negative x minus 1, x less than 1. So we can see here, when x is less than 0, this is negative 1. At the part of negative 1, they split the modulus function into two functions here. So we draw out our interval so that we can see it clearly. So you can see here, our changing point here, our x changing point here where we have x equals to 0 and x equals to negative 1. You can see less than negative 1, our function supposedly involving here is modulus. So x less than negative 1 function is negative x minus 1. And then when we have x more than negative 1 for this part, it will be the modulus part, right? So we will select x plus 1, okay? But still less than 0, so means more than negative 1, less than 0, this interval. So our modulus function, there will be suitable here, it will be in the function x plus 1. Then exactly on this point, it is value of this, value 2. Then our interval where x more than 0, it will be e negative 2x. So we can see for each part of the interval, each part of the domain, we have different function. So after we see it clearly, then only we can answer this limit, question of limit. The question of limit they are asking here is find the limit for x approaches 0 from the left hand side. So our domain x here, 0 is at here. When we come closer from the left hand side, so the function involving here will be x plus 1. So we will select the function x plus 1, and then we will try to solve this limit. So try to substitute our x equals to 0. When we substitute x equals to 0 inside, we get 1. And then continue for this part. When we have limit, when x approaches 0 from the right hand side, so the positive power and negative power, it tells us the direction. The direction whether you want to come from approaches left hand side or right hand side. So 0 come from right hand side. When you come to near from right hand side here, the function involving here is e negative 2x. Select our correct function, then only we try to evaluate our limit. We substitute 0 inside. So when we substitute 0 inside, we can get the answer E0. E0 also equals to 1. So is it this limit at the point they are same? They are axis? The answer yes, they are axis because this limit left hand side and right hand side, they give us same result. So we can give our reason here since our limit from the 0 left hand side of the function same with the limit from the zero, approaches zero from the right hand side. Therefore, we can conclude that limit at the point zero here, that definitely will equals to the result of 1. So that will be our first part. We're going to see one-sided limit, and conclude up the limit approaches that point. Okay, so we can see once we get the value, it means it's exists already. So you can like this, exists. But this question, they didn't ask us exist or not, right? So they asked us to evaluate the numbers, evaluate this answer. So we got answer, then we perform our answer. Okay, after we find the limit, they say hence, determine this function, is it continuous or not? So continuous or not at 0. So continuity, we have 3 conditions to fulfill. So the first condition is about the the coordinate point when x equals to 0, is it exist or not? So we can see at the coordinate x equals to 0, we have the point. So that point must be exist first. The coordinate 2 is exist, so means this is defined. Then condition number 2 is talking about the limit. So limit when x approaches 0 of the function, do it exist? So we found it from our first part of the question. This limit approaches function, it is exist, which is value of 1. Then the third condition here will be, is it the point same with our limit? So obviously our coordinate does not same with our limit. Our coordinate is value 2, but our limit approaches this function is value 1. So it doesn't same. So it doesn't get to the same result, means we can conclude that this function is not continuous at x equals to 0. Okay, so give your reason. So our reason will be this condition 3. The point does not same with the limit, because you can see if a graph, because our piecewise function here, we have piece by piece, point by point, whether it's continuous, whether it can link to each other or not, we have to see it clearly. At this point, the coordinate must come here. So we have a coordinate here, value of 2. When we approaches left hand side and right hand side, the graph come from left hand side and right hand side, but they approaches the value of 1. So it seems that when the graph 0 here, when we drawing, we have a point coordinate 2, but the graph approaches value 1 here. Approaches value 1. So this is value 1, this is value 2. Seems like we have missing a dot here, missing the coordinate here. So our graph cannot be continuous at the x equals to 0. So once if this graph approaches same with the point, means they can join to each other. They approaches value 2. If the limit approaches value 2, so our graph definitely can be continuous. It will not have a this continuous point here. Okay, so its marks, its important marks. It will be the first part, doing our this one, express our modulus function in piecewise. So expressions, give 1 marks basic. So next time you see your function in modulus, automatic, you know how split it into piecewise. Take the correct piece that regarding to the domain. Then evaluate our concept of select the correct function and find the limit. So for the right hand side and left hand side, they're testing on the same concept, whether you can identify or not left hand side, right hand side, which function that involving here. And then they say ask to find this limit at this point, right? So we have to know our concept where left hand side limit equals to right hand side limit, the limit at the point that exists, which is value of 1, the result of them. And then they said whether u continuous or not. So with the condition number 3, we state here they're not same concept. So we can come up conclusion. This is not okay. So it is 7 marks. So I have to, this one is not correct. 7 marks in answer scheme.